Hello my dear students, this is Akash HD. Welcome to the AHD physics classes. Hope you all are doing very good. So students, in this video we are going to solve the question from the chapter moving charges asked in a NEET 2018, and this question is based upon the force experienced by a current carrying conductor when it is placed in a magnetic field, and some concept of equilibrium also involved. That means we have to use Newton's first law of motion also. Okay, so let's go through the question. So the question is, a metallic rod of mass per unit length 0.5 kilogram per meter is lying horizontally on a smooth inclined plane which makes an angle of 30 degree with the horizontal. Okay, now the rod is not allowed to slide down by flowing a current through it when a magnetic field of induction, how much is given, 0.25 Tesla, is acting on it in the vertical direction. Okay, what they are asking in the question, the current flowing in the rod to keep it stationary is how much here. Okay, so when we will go through the question, we will note down the data here. The data is given here. First one, mass per unit length. See here, mass per unit length. That means if the mass of the wire is m and length is l, so I can write here m by l is given how much here. I can write here, see, 0.5 kilogram per meter. This is given. Next one, what they are telling that here, see this angle. How much angle is there? 30 degree. Inclined plane is having the angle also 30 degree here, no? Theta is given here 30 degree. Next one, what is given here? One magnetic field is there, no? See, magnetic field of how much value? 0.25 Tesla, or we can tell 1 by 4 also, magnetic field of induction, or we can tell simply magnetic field. So what is given here? We can write here 0.25 Tesla. Even you can write 1 by 4 Tesla also. Okay, and this magnetic field in which direction? They have mentioned here in vertical direction. Now in the question, what they are asking, the current flowing in the rod. Okay, so they are asking the current flowing in the rod. This is the question situation. Okay, kindly see very well. Now students, whatever they have given in a question, the same kind of situation we have to create it. Okay, so here you can see here, students, here I have taken here one inclined plane. Okay, and here you can see this kind of axis I will refer, x-axis, y-axis, z-axis outside of the board, and minus z-axis inside the board. Again I am telling that here, z-axis outside of the board and negative z-axis inside of the board. Okay, so here what is happening, that let's take this angle is theta, this angle anyhow also theta. This is, I am just showing here the three-dimensional view. Okay, so what is happening, that here there is the one wire is there. Okay, and in this wire what will happen, that the current will flow. Why the current will flow? Because the moment current will flow, then this wire will come in a magnetic field. Magnetic field in which direction? The magnetic field is given upward direction. So the moment the current will flow in the wire, what will happen? One magnetic force will act, and this magnetic force have to balance the force that is responsible to make the wire slide down. Okay, so remember that here, this situation I have drawn here. This is the wire here. Okay, this is the wire. I'll just draw here. See, this is the wire here. Okay, and remember that here in this wire, what are the forces will act here? See here. So if in case this angle is theta, you know very well, this side mg will act here, is it? And you know very well in a Newton's law of motion also, if this angle is theta, so what will happen, that here this side one component will be there, that component is responsible to make the wire slide down. Okay, and here I can do one more thing actually. Actually I am just going to make this force somewhat long, so diagram is visible properly. Now this is theta here. So what will happen, that this side one component will be there from parallelogram method. What will be there? This component you know very well, mg sin theta. This mg sin theta will be responsible to make the wire slide down. Okay, now after that this side mg cos theta will be there perpendicular to the plane, but that we are not interested. And after that what is given here? One magnetic field is there. This magnetic field in which direction? Upward direction is given. See, I am drawing here. Okay, so this is the magnetic field B. Now you think, if I write here the formula of the force, the formula of the force is vector F is equal to I, length of the wire, let's take here L cross B. So remember that here, IL cross B means when I will just curl my fingers of right hand from current element to the magnetic field, na right hand thumb rule, then what will happen that here this thumb will indicate the direction of what? Direction of the magnetic force. Okay, so what is happening that here we want that the magnetic force component should act in upward direction. Is it? That means anyhow the magnetic force should be which side? Right side or left side? Anyhow it should be right side here. Is it? So remember that here, see, this magnetic field is along which direction? If I take this component, this magnetic field is along y direction. See, this y and this y, magnetic field along y direction. Okay, now the current should flow in which direction? Remember that here, students. See, we have to curl our finger from current element to the magnetic field. So if in case current in a negative z direction, then negative z to y direction I will curl my all the fingers, then thumb will go along which direction? X direction here. Is it? See, see here I'm taking here, see, this is the current element, for example IL. Okay, and in this direction what is there? Magnetic field is there. See please, IL to B, then thumb is going in which direction? This direction. So this will be the direction of the force. Same concept if I will apply here, see, the magnetic force, this magnetic field is upward, is it? And see, this is the current direction here, like this here, along the negative z direction. Okay, like this, current will flow like this here, see, the current will flow like this, is it? So again, the force will act in which direction, students? If I will draw here, see, the force will act in this direction. Okay, which direction here we can see? X direction, see. So now students, after that, if I will draw here the components and all that here, is it? So see here, one component will be this direction. See, I have drawn here the component of this force now, and perpendicular also one component will be there, that we are not interested. Okay, so see here, if this angle is theta, this angle will become 90 minus theta. That means this angle will be how much here? This angle will be also theta. Is it? This is which force? Magnetic force. So this side component will be what here? This side component will be Fm cos theta. What is the component, students? Fm cos theta. Current is flowing in which direction? Along negative z direction. Then only Fm cos theta upward. If in case current is flowing in positive z direction, then Fm cos theta will be in this direction, along the plane, downward, and in that situation the wire cannot be in equilibrium. So definitely the current should flow in which direction? Along the negative z direction. Then only force will be along which axis? Positive x-axis. Otherwise wire cannot be in equilibrium. Okay, so remember that here after the students, if we talk about here, for wire to be in equilibrium, okay, for wire to be in equilibrium, what is there? You know very well, the wire should not move. So the force along the inclined plane should be balanced by force opposite to the inclined plane in opposite direction. That means we can write here, in this situation we can write, see, I can write here, see this one here, Fm cos theta is equal to mg sin theta. Okay, this is the thing. Now after that, see here, the magnetic force will be how much here? The magnetic force, if I talk about the magnitude, so the magnitude if I talk about here, see, the mod F, and here also I will take here the mod F. So then it will become here ILB sin theta. And what is the theta? Theta is the angle between current element and the magnetic field. Okay, so see, the current element in which direction? Negative z direction. Magnetic field in which direction? Y direction. So z direction, that means negative z direction, and y direction is making how much angle? You can see very well here. This is a 90-degree angle, is it? So what will be there? Anyhow, you can see here. And remember that one thing, this theta and this theta is not same. Okay, so I am writing here, see, I am writing some other angle here. Let's take, I am writing here alpha. Okay, and this is the alpha here. Don't mix up with both theta and theta. This theta is the angle of inclination, and this angle is the angle between the current element and the magnetic field. That's why I have taken here alpha. Here also I have taken alpha. Okay, so what will happen that here, this will be given here I LB, and anyhow sine alpha, how much here? Sine 90 degree into cos theta is equal to mg sin theta here. Is it? Anyhow, I'm telling this is alpha value. So from here I can write here, kindly see, ILB cos theta is equal to mg sin theta. Sin 90 anyhow 1 only. So from here, students, if I write here the value of I, so what is the I here? We can write here, see, mg by LB into sin theta, cos theta will come this side, that means it will become here the tan theta. Okay, so again if I will simplify this here, this is m by L, and then we can write here, see, g by B into tan theta here. Okay, so this is the basic. Now we have to just put the values here. Okay, so if we talk about here m by L, I remember the value, they have given 0.5 kg per meter, so 0.5. G value, to keep the thing simple, I have taken 10 meter per second square. What is the value of the B? Remember 0.25, that I have made it 1 by 4. Okay, I will write here 0.25. And theta, how much is given here? Kindly see very well, students. This theta is given here 30 degree. Okay, so if I will write here the tan 30 value, how much here? It will come here 1 by root 3. Okay, so from here you can see very well 0.5 by 0.25. It will go in a 2 times, so we can write here 2 into 10. See, if I will cancel here, see, this is 0.25, just 0.5. So it will come in a 2 times, it will cancel. So 2 into 10, 20, and 20 by root 3. Okay, root 3 value 1.732. So when you will simplify this, it will come 11 point something. Okay, so kindly check the options. Anywhere near to the 11 here, see, the option D is the near to the 11. Anyhow, what answer will come here? Near to near, we can tell here 11.32 ampere. Kindly say very well. Is it? So which option is correct here? As I have told you, option D is the correct answer. Is it? So students, I hope so this question based upon the force experienced by current carrying conductor in a external magnetic field is very clear to you. Keep studying, keep growing.